We're going to be having a look at exact values of pi on 6 angles. So pi on 6 is one of the other more common ones, and we can get a basic handle of what the values are going to be using just some basic trigonometry. Imagine for a second that we have an equilateral triangle. Well, its interior angles would add up to pi, which is 180 degrees, right? These would add up to pi, but since it's an equilateral triangle, each angle would only be pi on 3. Right? So this would be pi on 3, this would be pi on 3, this would be pi on 3. Right? And we could set any value for the sides. I'm going to set the values to being 2. So all of the sides are 2 units long. Now imagine that I split this triangle in half. Let's redraw just half of the triangle. Well, I know that this bottom angle would be a 90-degree angle. I still know that this bottom one down here is pi on 3. This length would be half of the full length, so that's 1, and this length over here would be 2. Question is, what's this angle up here? Well, pi on 3 divided by 2 would be pi on 6. We're nearly finished, we just need to work out the length of this side here. Now, a bit of Pythagoras Theorem is going to tell us that this side is going to be equal to 2 squared plus 1 squared, take the square root. Sorry, not plus, minus, which is going to give us square root of 3. Now, this is our triangle. I modify it slightly. I don't like all of these big numbers. Why? Because when we draw a unit circle, I want you to think about, where do they all fit? Well, this is always 1, right? That's what makes it the unit circle. The unit circle has radius 1. So what I'd really like is for this side, instead of being a 2, to be a 1. And if I want to do that, what I'd divide it by 2. So I'd have to divide the other 2 sides by 2. And this is the unit circle. Now this is one of our few triangles that's going to come up all the time, but I want you to notice a few little patterns about it. You'll notice that pi on 3 and pi on 6 are on opposite corners, and then opposite them we have a short side, which is this pi on 2, and the slightly longer side, which is this root 3 on 2. So now let's go through, and using a little bit of trigonometry, we should be able to go through and learn quickly how to work out some of these angles. So let's imagine I want to know cos pi on 6. Well, pi on 6 as an angle is about there. I often find it useful when doing sixths and thirds to break it down into sixths. So it'd be over to there. Now this point here has a long x-axis and a short y-axis. It's also in the all quadrant, meaning all sine, cos, and tan are going to be positive. Now, since the long side is the x-coordinate, it means that the long side is going to go first, and then the short coordinate's going to go second. So this would be root 3 on 2, comma 1. That's the point. And since we're interested in cosine, cosine's interested in the x-coordinate. The x-coordinate is then root 3 on 2. And we're done. Let's try a different one. Sine of pi on 3. Alrighty, so for the sine of pi on 3, well, we've got to redraw our little angle. So the angle would be slightly different. It would be this one up here. Now, a lot of people get confused when doing angles as to working it out. I often find it easy to remember that how many sixths it is. Counting in sixths can often be a helpful way of getting the angles right. So it's 2 sixths, right? 1 sixth, 2 sixths. So this here is pi on 3. And you can see here quite easily that there's a short x and a long y. Now, because of that, this point up here is going to be short x, 1 on 2, long y, root 3 on 2. And because we're in the all quadrant, they're both going to be positive. You can also think about it because this is the x and the y axis, and it's positive on both axes. Since we're interested in sine, sine is interested in the y coordinate, meaning our final answer is going to be root 3 on 2, and we're finished. Okay, so these are small angles. Let's do some larger angles just to get ourselves really comfortable. Let's do tan of theta in this case, and we'll make it 11 pi on 6. Alrighty, we'll draw our unit circle in, draw in our 6 lines. So that's 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6. And we're going clockwise out to 11 sixths. Now if you draw this, you'll see that x is long, y is short. What was the long one? The long one was root 3 on 2. And the short one was 1 on 2. But which quadrant are we in? We're in the we're in the positive x-axis and the positive cos, meaning this is going to be positive, the x-coordinate is going to be positive, and the y-coordinate would have to be negative. Which also makes sense because we're in the negative y section of the axis. So, but we're not working out cos or sine, we're actually working out tan. Well, tan is equal to sine over cos of the same angles. So sine of 11 pi on 6 over cos of 11 pi on 6. Well, that's the same as rise over run. Negative a half over root 3 on 2. Now both of these have a common factor of a half or over 2, so those can cancel and we are left with negative 1 over root 3. And that's the final answer. In the next one, we're going to be looking at the other angles that are potentially going to be coming up. In this case, it's going to be pi on 4.